Good afternoon. I would like to welcome everyone to our session this afternoon, and thank you all for joining us. I'm Jason Alayay, Senior Director of Software Engineering at LexisNexis Risk Solutions. Today, I have the privilege of introducing our speaker and assist him with Q&A. During the presentation, please submit any questions that you might have on your chat window. For those of you who are not as familiar with the platform, you can click on the letter Q at the bottom right corner of your screen to open the chat window. Our speaker is a senior software engineer with LexisNexis Risk Solutions. He has been with the company for more than 6 years, and all those years, he has worked on the HPCC platform. In his spare time, he enjoys building visualization tools and analytics tools on the HPCC platform. He is passionate about creating innovative solutions that improve user experience with the platform. In fact, the most recent tool that he developed is precisely that, a tool that enhances our HPCC users' experience. Outside of work, he enjoys reading about world politics and mythology. However, for today, he has more exciting story to tell us. And without further ado, please welcome Apaar Sinha. Apaar?
Thank you, Jason, for the wonderful introduction and a warm welcome to all of you. I hope that you're all staying safe in these unprecedented times and that also you're having a wonderful HPCC Systems Community Day. We have had some wonderful presentations since the morning, and I guess I hope that we'll have another engaging one here as well. So today I'll be introducing to you all a new data analytics tool that we are working here on at LexisNexis, which sort of aims to aid ECL engineers in their quest to improve the efficiency of their ECL codes. So without further ado, let's get started. So our story begins in ancient Greece, where once lived a ruler like the world had never seen. Yes, we are talking about Alexander III, more commonly known as Alexander the Great. But we'll not talk about any of his achievements as a military commander, but rather focus on a very small but interesting story, which is sort of relatively still unknown. So the story goes that Alexander once met a man who he thought was a monk or a sage. And the man seemed wise and was sort of respected by everybody around him. But in the eyes of Alexander, he seemed to be doing nothing, just sitting there idle, wasting his life. So out of curiosity, he asked the monk what was he doing. And so the monk replied that he's experiencing nothingness. And when the monk asked Alexander what he was doing, Alexander said that he was out to conquer the world. And so the both of them looked at each other and laughed. And in their minds, both of them thought that the other person is a big fool. So let's try and understand why each of them thought that way. So looking from Alexander's perspective, since the childhood, he had been told the story. And according to the story, when you die, you have to cross a river called the Styx. And once you get to the other side of the river, you're asked a question that whether have you done anything extraordinary in your life. If you have done something extraordinary, if you say yes, you are then sent to a place called the Elysium, which was basically a place reserved for the heroes. Otherwise, you were sent to the asphodel fields, which was basically a place for the commoners. So in essence, Alexander all his life was told to achieve as much as he could in his life, since at the end of his life, the value of his whole life would basically be the sum total of his achievements. So you could feel that sense of urgency around him. On the flip side, the monk, however, had heard a different story. He was also told about a river that you have to cross when you die, but you do not cross it just once. Instead, you go to and fro infinitely many times. And hence, the value of the monk's life now became 0 because the denominator, instead of being 1 in Alexander's case, just becomes infinity in the monk's case. And so whatever he achieved in his life that didn't really matter, right? And if anything you do doesn't really matter, in that case, what do you do? So he introspected, and he thought about what is the purpose of his existence? What is the meaning of his life? And so if some of you are thinking that we are at the wrong conference at this point of time, please bear with me. We'll shift gears and get to the tool. But before that, let us just shift our focus to ourselves now and try and look at the two stories from our perspective and try and determine who are we more alike. Do we have more of Alexander in us, or do we have more of a monk in us? And I guess in this fast-paced world where we are all rushing headlong into taking on as many projects as we can and taking on as many challenges as we can, delivering tasks as quickly as possible, it's safe to say that I guess most of us have more of an Alexander in us than the monk. And so if we as ECL engineers are like Alexander, then maybe it might not be too wrong to say that HPCC is like our army, a vast army ready to serve at our command. And in HPCC, we have a wonderful army. I think we all here belong to the HPCC community, so I do not have to spend too much time on emphasizing the fact of why HPCC is great. But the point that I want to send across is that HPCC is extremely powerful. With that said, it's still not too difficult to write bad ECL code. As the saying goes, it maybe takes a week to learn, but a lifetime to master. And so if we try to think about why that is the case, we can maybe narrow it down to a couple of points. First, that there's a high degree of abstraction in HPCC. So HPCC takes care of a lot of things under the hood. And it is quite common for a coder to be unaware of how actually their code is being compiled or executed. And second, a lot of the times bad ECL code is actually difficult to find, right? It might still compile. You might still be able to execute it without errors, and you might still have the outputs that you intended to have, but maybe the output file is extremely skewed, or maybe the ECL code is taking 5 times longer than it actually should take to run. And so a lot of times, unless something really breaks down or maybe considerably slows down, no one really bothers about analyzing their code. And so why don't we, so why is that the case? Why don't we always analyze it? And if we do have to analyze it, what are some of the ways that we can do that? So we'll quickly take a look at what are some of the traditional ways that we can go about analyzing a work unit. We talked about introspection a while back, so let's talk about work unit inspection now. And so the most common way that engineers do it at the moment is basically to look at their ECL graphs. And now graphs are like a blueprint of a building, right? They are extremely informational, but they only make sense in the hands of a very few. And like the blueprints, graph contains a ton of information, more than actually the engineer could hope for, but they can very quickly become very complex and intricate for the engineers to gain any insights from them. And the reason why they become so complex so quickly is because every single ECL statement can have upwards of like 20 metrics, right? And an average ECL code can have hundreds of such ECL statements. So as you can see, very quickly, it becomes almost like a nightmare for the engineers to be able to, take in thousands of metrics at one go. And it's almost like solving a large jigsaw puzzle. You were a few minutes into it, and you still realize that you haven't made any progress. And so to tackle this problem, there have been certain upgrades that have been made recently, especially with the introduction of the Work Unit Analyzer tool. And this tool does a lot of the heavy lifting work for the engineers. It goes through the graphs and systematically passes all of the metrics through an engine to generate the insights. And it does all of that at like almost instantly right after your work unit has completed. So which is wonderful. However, you might still realize that there is still some room of improvements. There are some gaps that are yet to be filled, right? First, that we are still bound within the HPCC ecosystem. And second, there is a scope to improve the analytics, to generate some aggregated stats, or maybe perform some work unit comparisons, right? So to fill in these gaps, we have the HPCC Analytics Tool, and we'll take a look at it now. And there are three main sections that we will focus our presentation on going forward. First, we'll take a look at an overview and the tech stack of the application. Second, we'll run through a couple of examples. And third, we'll talk about our whole development journey, where we are at and what's coming up. So HAT is basically a web-based data analytics tool, which is completely built in the .NET framework. It interacts with the HPCC by making asynchronous HTTP calls to the web services exposed by HPCC. And finally, it allows users to integrate their native systems with this tool so that they can get access to all of these stats and metrics in their own systems. And we'll talk about all of this in the upcoming slides as well. So let's take a look at how the tool actually works under the hood. So when a user submits a request to run a new graph analysis or a comparison job, the tool reaches out to the HPCC to gather all of the raw information. And once it has all of the data, it then feeds it to a parser, which basically divides all of the data into 4 chunks or classes, one each for graph, subgraph, node, and edge. And then it sends all of this parsed data through an analytics engine, which runs through all of this data and sort of computes all of the metrics. And both these parser and the analytics engine have been fully written in C# at the moment, and the analytics engine uses a bunch of link queries for computations. And once all of these metrics have been generated, it basically ships them over to the front-end web application for display purposes, and also logs some useful information into a MySQL database. So moving on to a front-end design, it's basically based on the Google's material design principle. The application itself is extremely responsive. So all of the elements sort of resize and reorder based on the screen size. The application is also configurable. So right from the UI, the users can set certain thresholds and filters. And finally, the application is also highly interactive and user-friendly. So they can set they can set the type of columns that they want to see, reorder the columns, do dynamic filtering, and things like that. And let's also take a quick look at the features of the analytics engine. So based on the functionality, it can either be used to perform graph analysis, or it can be used to do a work unit comparison between 2 ECL jobs. And from the metrics perspective, it computes both high-level aggregated stats as well as node-level or drill-down statistics. So now that we have looked at the overview of the application, let's go through a dry fire round where we'll run through a couple of high-level examples, each for the work unit analysis and a work unit comparison job. Okay, so this screen actually gives you the idea of the look and feel of the application. What you see here on the screen is basically the homepage of the web application, where the user is required to enter their HPCC credentials for logging in. And once they are logged in, they are directly led to a Launchpad page, which gives them an option to either start analyzing a work unit or to compare two work unit jobs. So when a user submits a request, it takes a few seconds to fetch all of the raw data and compute the metrics. Once the final result is ready, this is the screen that shows all of the results. And this result is basically of the result of a graph analysis done of a dummy small ECL code. And you'll notice at the top that there is a navigation bar showing a number of options, and these are the different types of stats that are available for a user on the screen. And so in the interest of time, we will not go through all the metrics here, rather just look at a couple of them to give you an idea of the type of information that's available here. So in the screen, what you see here are the KPIs, which are extremely high-level stats, but also very valuable. So you have things like total process time, cluster time, and compile time. And you also have, on the bottom row, stats like the overall disk read times, disk write times, spill, and sort times. And these bottom four metrics are basically high-level aggregated metrics. And so they are basically a summation of all of the nodes that have performed that respective activity. And the blue links that you see below each of those four KPIs on those cards are basically links that will take you down to the activity level information. So basically helping you to drill down to the lower level stats. And after that, now that we've looked at the KPIs, we'll also take a look at another set of stats that it generates. So we'll look at the labels section. And this section is quite interesting because it shows the total time taken for execution grouped by distinct ECL operations. So for example, in this particular work unit, of all the operations that it had to do, the maximum time that it spent executing was it was doing sort, followed by split, and then followed by join. And so this gives us some useful information, right? Like which ECL operations are being most frequently used. You have the count column towards the right. And also how long are each of the ECL operations taking to execute in your particular code. And so finally, I also want to show you the results of the work unit analyzer tool, which the engineers can directly view on this tool as well. So the left highlighted box is basically contains the message coming out of the work unit analyzer tool. And it also shows the associated priority value and also the corresponding ECL text and the attribute name. Now, this feature to view the message along with the ECL text in one go sort of saves the additional effort for an engineer to first look at the message and then locate the ECL text on the ECL watch page by sort of navigating through the whole graph based on the specified scope. So this was basically a high-level example of the work unit or the graph analysis portion. Let's also take a high-level look at how the work unit comparison works, or what benefits can we gain from comparing two jobs. And so the work unit comparison actually works at two levels. One, it compares the graph structure. And second, it compares the metrics of the generated for the two work units or the two jobs. So first, let's look at the graph structure comparison. The purpose of doing or comparing the graph structure is to basically determine how similar the two graphs are. And the two work units that I've used here in this example have the exact same ECL code. However, they were just run at different times. So we begin by comparing the counts of the graphs and subgraphs and nodes and edges. And you can see here they're all the same. And then we take this a step forward and calculate a couple of scores called the node similarity score and the edge similarity score. Now, the node similarity score is basically the percentage of nodes that belong to the second work unit that have the that belong to the same subgraph, and that subgraph belongs to the same graph as compared to the work unit ID 1. And we do not stop there. We also compare whether the two nodes actually ran the same ECL text or not. And based on that, we can calculate the percentage. And similarly, we have the edge similarity score, which is basically the percentage of edges that join the same two exact nodes in both of the graphs. So using these two scores, we can actually determine how structurally similar the two graphs for the work units are. And in this case, as you can see, they are identical. And so we compared we looked at the comparison of the graph structure. So now let's look at the comparison between the metrics. And so in the table that you see on your screens, we have a comparison of the topmost level of the metrics, like total process time and cluster time. And you'll notice that the second work unit roughly took 27 minutes more to process than the first work unit. And very quickly, we can see that a portion of that can be explained by the additional 11 minutes that the second work unit took to just wait in the queue, which is essentially denoted by the non-cluster time in the third row. So we are still left with about 16 minutes of unexplained delay still. So we drill down from that and we look at aggregated ECL level operational metrics, right? So, and these, if you recollect from a few slides earlier, are basically some of these are what we looked at in our KPIs as well. So now, if we look at the table very quickly, we can see that there is a significant jump in the second work unit ID for doing the disk reads, almost a jump of 50% compared to the first work unit, almost took 16 minutes more, which sort of fully explains the total difference in the process time of the two work units. So now, once equipped with this insight, now the ECL engineers can go in and take a look at their individual disk read ECL statements and sort of determine which of those took the longest or which of those were causing the actual delay. Maybe the file in the second work unit that they were reading was a larger file, or maybe it was not very well distributed, and so there was skewness, and which was essentially slowing down the read process. And they can do that all on the same tool itself. They do not have to go into different places, on the same tool, on the same screen. So it all makes it quite easy and very fast to do to perform both work unit analysis as well as compare two different jobs. So now that we have looked at the overview of the applications, and we have also looked at a couple of examples for both graph analysis and work unit comparison, Let's take a step back and talk about the project development lifecycle, where we are at, what are the next steps. But before we do that, let me just pause here to take a few audience questions if we have.
Yeah, Apaar, we have a couple of questions.
Sure.
The audience. So let me start with the first one here. What are some of the limitations that you have encountered with the tool?
That's a good question. So limitation-wise, I guess, so the only real limitation is that this tool requires a couple of the web services which are only present in platform post 7.0. So if you are on a platform post 7.0, there's really not any limitations, because but otherwise, if you are not on 7.0 or if you're before that, this wouldn't work at this point of time. So that's, I guess, the only sort of limitation of the tool.
That's great. Thank you, Apaar. Will it work with archive work units?
Oh, perfect question again. Absolutely. Yeah. So you do not have to worry about restoring your work units manually before having to run the analysis. Just give it the work unit ID and give it which HPCC environment that it belongs to. And if it is an archived work unit, it will auto restore that work unit for you before fetching all of the graph related information.
Awesome, thank you. Another question here, is there a capability to add a custom metrics? I think it'd be great if you can configure the tool so that you can customize the metrics that is available on the tool. Is there a way to do that?
Absolutely. So we talked about how modular and scalable the code is. So if you have metrics that you would want to be included on the tool or on the application, or there's some other sort of analysis that you would want, that would be a wonderful thing. This is one of the reasons why we are presenting it here, so that we can get as much feedback as we can and include all of those feedbacks as much as possible to make this tool as powerful as possible and as useful as possible for everybody around.
Awesome. Okay, another question here. Does the tool, is it available from ECL Watch?
It is not available from ECL Watch at the moment. It has its own separate URL. So you have to basically open a new tab and open this tool separately. But that's a good suggestion. Maybe down the road, we might think of having a button from the ECL Watch page itself to take you to the analysis page right away.
That would be great. I think you can access the graphs from ECL Watch, right? So it would be nice to have this tool from the same ID as well. You just received a nice compliment from Flavio. He said this tool is brilliant.
Oh, thank you. Appreciate that.
Yeah, so do you have any plans to improve the tool so that it can also prescribe improvements on the work unit?
We do. And that's something that we'll cover right in the next segment as well, about where we are at and what's in store in the future.
Yeah, I think Flavio thinks that will be a great help for a lot of ECL developers. So I think that will be a great improvement.
Okay.
We have another question if you have time, Apaar.
Sure.
So can we compare two work units present in different environments? Or do they need to be in the same environment?
So technically, you can compare work units in two environments. If there is a need to do that, you can absolutely do that. This tool will have the capability. So for every environment or for every work unit, you have to specify its individual environment. So if it makes sense in any way to do such a comparison, we can do that, yes.
Sounds good. So maybe we'll take another question and then you can continue the presentation apart, and then we'll take questions towards the end. Is this tool currently open source?
Yeah, that's a good question. So not open source at the moment, but we have plans of doing that, and I'll talk a bit about that in the upcoming slides as well.
Okay, sounds good. Very good. Thank you, Apaar.
Sure, thank you. And some wonderful questions there. Glad to see that it's you're all liking it, and it's also good to have some engaging audience as well. So appreciate that. So as we were talking about, we just looked at the overview of the application and we looked at a couple of examples. Let's now take a look at how this project came about, where we are at, and where do we go from here. So this whole project was sort of conceptualized towards end of Q3 or maybe early Q4 of last year. So maybe exactly around this time last year. And we created a couple of prototypes. The first one actually, the first prototype actually had the, or required the engineer to actually do the parsing and the analytics part in ECL itself, which was working fine, but it was sort of limiting us in some way, because again, you're waiting for maybe like an availability of a free cluster and things like that. So we actually dropped that plan and moved ahead with the development with the second prototype, where we took all of the parsing as well as the analytics part of it outside of HPCC completely. And so by end of Q1, I would say roughly we had a beta version that we introduced to a couple of our internal teams for testing. We had some bugs, obviously, to fix. And once all of that was flattened out, by early May, we released an MVP version. However, as the name MVP suggests, we have just taken a few baby steps towards our final product. There's still a lot of work yet to be done on this tool. So what are some of the use cases or where has it helped us till now? So one, obviously, for analyzing and gaining deeper perspective of our ECL jobs. Using this, we can now quickly answer questions like which ECL operation is taking the longest, or how long is my work unit spending time doing input-output operations. Second, we have also used it to compare two jobs. And this has come in very handy in cases where we suddenly find that one of the jobs considerably slows down compared to its usual runtime. And so then we can compare two work units before and after it's slowing down and sort of pinpoint where the pain areas actually are. And third, we can use it to integrate it with other systems as well. So for example, if you attended Roger Dev's breakout session earlier today on Data Lake Deep Dive, he mentioned about a tool called Tombolo, which can be used for data governance and defining workflows. So we are working at the moment to integrate this tool with Tombolo as well. So Tombolo users will have the capability from their tool itself to sort of go in and submit an analysis job and view all of these metrics and have all of this analytics capabilities of HAT in there as well. And one point that I want to stress, and I cannot emphasize more, is that with all of its good capabilities and all of its benefits, the tool is just an aid to the engineer. It does not go in and fix the error or provide the solution, but it just provides an easy way for the engineer to determine where could be the potential issues or potential areas of improvement in their respective codes. And so what lies ahead of us at this time? We are working on a number of things at the moment. The top priority is basically to take this code from the .NET framework and convert it into a Node and React-based framework, after which we have plans to make it available to the community as well. We also have plans to further increase the analytics capabilities. Things like maybe comparing the C++ codes that's generating under the hood, or maybe having the capability to compare the compiler directives, which can have a significant impact on the way the code gets executed, and also improving some of the data visualizations on the tool as well. And finally, there's also a plan to build a recommendation system within the tool, which will sort of provide the users with some common tips and suggestions based on some of the ECL errors that they receive, or maybe some of the compiler warning messages that they receive, so that it gives the engineers some sort of a starting point of where they can go in and try out different ideas to solve their respective problems. And so that's it. But before we close, let me do a quick recap of what we discussed today in the presentation. And so if you weren't paying attention before this, just use this slide as your takeaway. So HAT is basically a web-based analytics tool that users can use to either perform single graph analysis or do word unit comparison. And they can also use it to integrate this with other tools in order to take the analytics capability outside of HPCC. And finally, we looked at the fact that how easy and efficient and intuitive it makes the whole process of analyzing and comparing jobs. So I hope that I've inspired some of you to restore the balance between your monk and the inner Alexander. Maybe think about some of the projects that you may be working on, some of the codes that you are working with, if they are the most efficient code, if there is a room of improvement there, and things like that. Ask those questions which we generally skip over. Finally, curiosity. We all know that curiosity killed the cat, but I guess we all have a lot of scope to enhance our curiosity without being, coming into that danger of getting killed. So with that, I thank you, all of you, for joining us today. It was an absolute pleasure for me to present this tool on this wonderful platform. And we will open the floor for questions now, but in case we miss some, or if you have additional questions, please feel free to get in touch with me in Social Lounge, or you can also directly email me. The email ID is up on the screen. So with that, I thank you all again and open the floor for questions.
Apaar, we still have a couple of questions before we close.
Sure.
They were entered in a different thread, but I was able to capture them.
Okay.
The first question is, do you see any benefits of using this tool in our migration from on-premise to the cloud? Do you see this tool being useful in a migration process?
Absolutely, and that's a very insightful question as well. So yeah, absolutely. Even when we migrate to the cloud, I think it will become of more importance to be able to analyze your job, because now you would be able to sort of assign a dollar value, if you please, to the to each ECL operation. So now you can go in and look into the tool and say like, okay, of all the operations, my join is costing the most and it's costing roughly about X dollars or things like that. But absolutely, it will continue to be useful, if not more, after our migration to the cloud.
Very good, thank you. And then the next question is similar to the one I just asked a few minutes ago, but it's slightly different. This says, could we access any features, maybe not all features, any features of the tool in ECL Watch?
Again, so the answer is that not at this point of time. This whole tool, this whole framework is actually a separate framework altogether. The only interactions that it has with HPCC is that it calls out to the APIs for fetching the raw data. But at the moment, there is no capability in ECL Watch page to go to this tool right now, but that is one of the things that's also we can take a look at and maybe have at least some portions of it included in the ECL Watch as well.
Very good, thank you, Apaar. And you just received a couple of compliments from the audience. They both said, excellent presentation, great presentation. And someone is typing another question, I believe, so let's give him a couple of seconds.
Sure.
If you don't mind.
Absolutely.
I think we still have a few minutes left anyway, so. Yeah, we still have a few minutes left, so if you have other questions from the audience, this is a good time. Apaar, so how did you find time developing the tool?
Good question. So it all started actually as a pet project, as a side project, and we all, as a small team, we realized its benefits. So we started working on the side whenever we found some free time. But slowly, it really caught the attention of everybody around, and before we knew it, sort of blew up significantly, and everybody whom we introduced the tool to sort of was able to see its benefits, and yeah, and from there we got the impetus to actually spend more time and make it as a mainstream project.
Yeah, was there a specific, being as an ECL developer, was there a specific pain point or pain points that motivated you to develop a tool like this?
Absolutely, yeah. So I guess the biggest pain point for us was the time it took to really analyze or go into and look at the graphs and make insightful decisions out of it. We talked, or there are a few people on the team as well who maybe might not be as familiar with all of the metrics, right? And all of the metrics, there are a bunch of metrics as well, and maybe sometimes the name changes, or people might not be aware of what those metrics really mean. So overall, we felt that it's the whole there are gaps in the process, and we can do some things to sort of improve the whole method of doing the analysis work. And obviously there were some times where maybe we were doing it, it was the peak times, we had very high load. So during those times we were having trouble actually going to the ECL Watch page, and even loading the graph maybe took us like 30 seconds or maybe 45 seconds to do that. And so if you're doing an analysis kind of a thing, you want to be able to switch from different screens very quickly. You want to be able to look at different portions of the graphs. And so if it takes like 45 seconds for one page or one snapshot to open, it's really not the best way to analyze something or gain insights out of it. So yeah, that was actually our starting point of where we got the idea of doing this.
No, that's great. I can relate. I wish we had a tool like this when I was developing years ago. But great job. Thank you, Apaar. One last question from the audience. Will there be any changes to the APIs when the clusters are running in Kubernetes in the cloud?
That's a good question, and a question for which I do not have an answer for at the moment. That's more for maybe the platform team to answer, some of which, if you want to get more information, I think there have been some wonderful blogs already written on those topics, which are up on the HPCC Systems website. So I'd recommend you to go there and read up those blogs that might have more information about the changes that would go into the platform with all of the migration to the cloud.
Sounds good. We just, I think we still have a couple of minutes, so we have a couple of comments from the audience here. We just received another compliment. She said, "This is an awesome tool. I can already see how my code can run more efficiently after getting the result from this tool. For work unit comparison," this is a question, "will it be able to tell the most time-consuming code for both work unit?"
Absolutely, it can. So not only does it give you the capability to look at high-level metrics, but you can drill down to actual activity level metrics and do a comparison at the activity level. So you can actually look at the actual ECL code or ECL statement, which is causing the maximum delay in one of the work units.
Okay, very good. Okay. One last compliment. This is great, Apaar, very impressive. And so with that, that concludes our session this afternoon. Up next, we have exciting plenary sessions before we close the day today. So we encourage everyone to attend the plenary sessions. Thank you again, Apaar, for the excellent presentation. And thank you all for coming.
Thank you.
Thank you.